Okay, using this concept that calculus was used to describe where electrons are located outside of the nucleus is where the n 1 through 7 that you labeled your periodic table with came from, okay? It is a quantum number. Quantum numbers describe where electrons are located in terms of energy levels, atomic orbitals, and whether they're spinning up or spinning down. So the principal quantum number n tells us the size of the atomic orbital that the electron is in. So n equals 0 would be the smallest, or n equals 1 would be the smallest, n equals 7 would be the largest, okay? Now, past that, we jump into the second quantum number, L. Okay, so what I'm going to do is I'm going to go to the periodic table that I gave you, and we're going to label this. Okay, so the reason I asked you to get 4 different colored pencils is because beyond the ends, think of what I'm about to do as if you're on a different floor of a department store, there are different sort of like sections within the department store, right? So like Nordstrom on the first level has shoes, men's makeup, purses, okay? So think of that as the subshells, which I'm about to color code for you, are the different sections within the energy levels or the floors of a department store, okay? So this first one that I'm coloring for you, this is going to be the S subshell. So the shells are often going to be referred to as the N equals 1 through 7. Subshells will be S, P, D, and F. So I'm going to put the letters over the regions that they pertain to. So this first section are the S's. I am going to cross out this hydrogen because I don't want you to use it because we already have hydrogen written on the left-hand side. So this hydrogen is really not relevant to what we're doing. Okay, so that's out. Okay, next I'm going to get a different color. And I'm going to color this entire section on the right-hand side yellow. And this is the P subshell. Okay, and then I'm going to color the middle blue. Okay. These are the D's. And then on the bottom, these are the F's. Okay, so the N's are part of the course, but there's the additional quantum numbers are going to be bonus on your test, okay? So you still need to know like S, P, D, and F, but I'll explain. So after the N in your book, it goes to the second quantum number L, which is what I have coded for you on the periodic table. I just haven't labeled it that way. So let me explain. So the L tells you, so the N gives you, what does it say in your book? The size of the orbital. So this is the size of the orbital, okay? In your book, it says that L is the shape. So this will be the shape. So your L can be 0, 1, 2, or 3 for values. What that means is if it's a 0, it's an S. If it's a 1, it's a P. If it's a 2, it's a D. If it's a 3, it's an F. Okay, so on the periodic table, these two columns would be where my L is a 0, because those are S's. And then over here where I have helium, this would be where my L is a 0. And then my L is a 1 here, where I have my P's. And then my L is a 2 here, where I have my D's. And then my L is a 3 here, where I have my F's. Okay? Okay, now the third quantum number in your book is called the magnetic quantum number, and it is labeled M sub L. Okay, it's a little script L. And what this tells us is the orientation in space, meaning which axis essentially is an electron on. It could be the x-axis, a y-axis, or a z-axis, for example. And this is based upon whatever my L value is, and I'll have a plus or a minus in front of it. Now let me explain this, because this is really easy to figure out based upon the location on the periodic table. Okay? All right, so I'm going to write these M sub L's above each column to give you a guide. Since my L value is 0 here, my M sub L value is based upon this number. So that means my M sub L could only be a 0. And the reason why is because the S's are spheres. So the electrons that are in an S subshell create a spherical cloud shape as they move around the nucleus. Okay, so once I move over here, so this will be a 0 as well, because my L is a 0 here. So they aren't on a particular axis, if that makes any sense. Okay, so they're in this cloud-like spherical shape. If I'm in a P, the P's are a dumbbell shape outside of the nucleus. So the electrons in the P's are moving in these dumbbell-shaped clouds. I have one on the x-axis, one on the y-axis, and one on the z-axis. So I have to describe where the electrons are located. How do I do that? Since my L is a 1 My m sub l is based upon this number. You start with a -1 here, and then you go to 0 and then +1. Think of it as oscillating from x to y to z axis. Then I go back to -1, 0, +1. Okay? You don't need to know which axis the electron is on. You just need to know that the possibilities for m sub l would be -1, 0, and +1. Okay? And for L equals 2, the possibilities for m sub l would be -2, -1, 0, +1, +2, -2, -1, 0, +1, +2. Okay? And then down at the very bottom, for L equals 3, my m sub l values would be -3, -2, -1, 0, +1, +2, +3, -3, -2, -1, 0, +1, +2, +3. Do you see how it all fits perfectly? Okay. So if this is confusing, let me sort of explain to you a couple of things. So if I'm looking at a nucleus, so here's my nucleus, and I have electrons in the 1s subshell. The 1 comes from this n equals 1. That means my electrons would create a cloud around the nucleus that's spherical. If I have electrons in the 2s subshell, it would be a bigger sphere because my n value is larger. Okay? Over here, if I'm looking at the p's, which are a dumbbell, if this is a y, x, and z axis, you will have a dumbbell-shaped cloud on the x-axis, and you would have a dumbbell-shaped cloud on the y, and a dumbbell-shaped cloud on the z. Electrons, since they're negatively charged, they want to get away from each other. So what happens is an electron will occupy, let's say, an x-axis first, and then it will go to a y, and then it would go to a z. So they're just trying to get away from each other, hence the reason we have these oscillating numbers that describe where the electrons are. And then the electrons will go and they will pair up. Now I have one in the x, now I have one in the y, and then I have the last one in the z. Does that sort of make sense why these numbers oscillate the way that they do? And then over here, in the d's, these are actually clover leaf shaped. I can't draw these. It's too complicated. Okay? And then the f's have no specific shape. So as a bonus on the test, I basically give you one of these periodic tables and ask you to label it, just like I did. Does that make sense? Okay. And yes, yes, it's your choice whether you want to do it or not. Okay. All right. Now the last quantum number, you have to turn a couple of pages, and I'm just going to write it on here before we go back to the book. The last quantum number is the spin quantum number, m sub s, and this one describes whether electrons are spinning up or spinning down. This will make more sense when I explain a few things in a second, but the only possibilities for this value are a plus or minus 1/2. A plus 1/2 describes an electron spinning up, so plus 1/2 would have an arrow or a half arrow spinning up to represent an electron in an orbital. And then the minus 1/2 is an electron spinning down in an orbital. Okay? You don't know which is which. That's something that you can talk about later on if you take like OChem in a lab or something like that. But that's it in terms of labeling. Okay? I'm going to go back to the book. We're going to use this. But we're not going to use all the quantum numbers except for the n's. Okay, so let me stop this. I'll bring it